Good day, everyone. Welcome to the next Redfish School training session. I am John Mayfield from Hewlett-Packard Enterprise, and today we will go over the Redfish support for Compute Express Link. In this session, we will do a quick overview of CXL technology. We'll discuss the chassis and system models for CXL, including the PCIe device function, CXL logical device, memory domains, and memory chunks, and how they support CXL devices. We will also go over how the different local CXL devices are modeled, as well as modeling remote devices across a CXL fabric. We will then go over some example Redfish resources for CXL devices. CXL is an open industry standard for high bandwidth, low latency interconnect defined by the CXL Consortium. This interconnect provides connectivity between host processors, accelerators, memory devices, and SmartNICs. CXL is based on the PCI Express PHY layer, leveraging the PCI Express infrastructure already established in the industry. CXL links support both PCI Express devices as well as multi-protocol CXL devices. CXL defines logical devices where resources can be partitioned and bound to different hosts or components needing to access those resources. There are three main use cases for CXL at this time. Type 1 devices that are typically accelerators or caching devices that utilize the CXL.io and CXL.cache protocols. Example uses are for PGAS NICs or NIC atomics. Type 2 devices are accelerators with memory on those devices. These devices utilize CXL.io, .mem, and .cache protocols when interacting with a host processor. Example uses would be GPGPUs or devices used for dense computations. Type 3 devices are for memory buffers, typically used for memory expansion. These are memory buffers using CXL.io and CXL.mem protocols for uses like memory bandwidth expansion, memory capacity expansion, or storage class memory. Management of CXL devices is built upon the Redfish PCIe model, including PCIe devices and PCIe functions. CXL devices can provide standard PCIe function as well as extended functions with the new CXL cache and memory semantics. We've added the new CXL logical device to the model to allow partitioning of device resources and binding them to one or more hosts through a CXL switch. All PCIe functions supporting CXL extensions associated with logical devices can use resources referenced by these devices. Let's move to the chassis and system model for CXL devices. CXL devices are not always bound to a host physically. They could be in a separate chassis and accessible through a CXL switch or fabric. Because of this, we have CXL device objects defined in the chassis model. The chassis model describes resources within a chassis. Remote accelerators attached to a CXL fabric can also reside in the chassis model. In the chassis model, a PCIe device describes that CXL device in the chassis. A fabric manager for the chassis with a Type 3 device can create memory chunks for host assignment through logical devices. Devices in chassis are remote resources. Shown here is a remote processor, but other resources could be represented here as well. In the system model, we describe the host that is attached to the CXL fabric. Ports of the processor describe how the system is connected to the fabric. The memory model can contain remote memory describing memory bound to the host over a CXL fabric. Memory domains in system can describe locally attached CXL memory and/or remote CXL memory. A memory chunk in system describes a region of address space that is backed by either local or remote CXL memory. This memory can be interleaved or a contiguous range across local or remote memory devices. The memory model describes a logical memory device representing memory that is assigned to the host over a CXL fabric. Next, we'll go into the local CXL device models directly attached to a computer system. In this diagram, we show a local Type 1 CXL device that is directly attached to the host CPU. This CXL device has one PCIe function and one CXL logical device. A local Type 2 device has a GPU processor in the CXL2 chassis and assignable memory in that device. So we have memory domains and a memory model to represent the memory component of the Type 2 device. The GPU processor is directly connected to the host CPU processor. A memory chunk is defined in the device's memory domain and is assigned to the local CXL system. This CXL memory is represented as CXL2 in memory and has a memory media source as the memory chunk defined in the CXL device. In a local Type 3 CXL device, we have a memory expansion device. The device is represented as CXL3 in chassis with a PCIe device and a PCIe function. There is also a CXL logical device that represents the memory on the device and a memory chunk representing the assignable memory region. In a CXL system, we have a CXL3 memory device that represents that memory chunk defined in the memory domain from CXL3. This is represented as a memory media source in CXL3 memory in CXL system. We also can have remote CXL devices over a CXL fabric. So let's go over remote CXL devices. This diagram describes a remote CXL accelerator device across a CXL fabric connected to a host system. Again, in chassis, we have PCXL1 device that has a PCIe device, a PCIe function, and one CXL logical device. We also have a fabric adapter and a port to connect the device to a CXL fabric. The main difference in this diagram is the addition of the fabrics model, which includes a CXL switch, upstream ports, downstream ports, and endpoints and zones. The Type 1 device is assigned to the CXL system via CXL logical device in endpoint T1. Fabric switch has a port that connects to the fabric adapter port and the processor port in CXL system. Now we're starting to get complicated. A remote Type 2 device, similar to the Type 1 device, now has a fabric model representing the CXL fabric that provides connectivity to the CXL device and to the host system. In the chassis PCXL2, we have the PCIe device function and a CXL logical device for the assignable memory. We have a memory domain and memory that represents the memory on the remote CXL device. We have a GPU processor and a memory chunk that is assignable region of memory in the CXL device. The fabrics model has a switch with upstream and downstream ports. The host system and remote CXL device are endpoints on the fabric and are within a zone that allows them to communicate. There is a connection that describes the connection between the host processor and the remote memory chunk. Remote CXL memory is represented as RCXL2 in the CXL system's memory, as it is remotely attached memory. The CXL system has a memory chunk that represents a memory region from the remote CXL device over the CXL fabric. Remote Type 3 memory is similar to remote Type 2 memory, except that there is no remote processor available. Fabric model is similar, representing the CXL memory with a switch containing upstream and downstream ports. There is a zone that allows traffic to be transmitted between the initiator and the target endpoints on the fabric. There is a connection that describes the CXL system being connected to the remote memory in the Remote CXL device. The chassis has the Remote CXL device with the PCIe device function and a CXL logical device. There is a fabric adapter with a port representing how the remote device is connected to the fabric. There is a memory domain and memory representing the memory on the Remote CXL device, and an assignable memory chunk for the region of memory that is assigned to the host over the CXL fabric. In CXL system, we again have our CXL3 representing the remote memory of the Remote CXL device, and a memory chunk representing an assigned region of memory in the CXL system. Let's look at some example Redfish resources for CXL device. As a remote logical device, Redfish has the semantics supported by the device, the current QoS settings for the CXL device, the total size of the logical device, and pointers to the PCIe function, memory chunks, memory domains, and endpoints that are part of the CXL logical device. This is the Redfish resource for our CXL3, the remote memory model in CXL computer system. This describes the capacity of the remote device and endpoints on the fabric and the memory media source for the assigned memory region. Here we have the memory chunk in the remote CXL device, which is in the chassis model. This memory chunk describes the chunk size, the memory type, and the offset within the CXL device for that chunk. We also have the links to the logical device that is exporting this memory chunk and the endpoint on the fabric that represents the CXL device on the fabric. There are additional resources available to better understand details of the CXL model in the CXL public mockup on the DMTF website at redfish.dmtf.org. We also have a fabrics white paper that describes the fabric model in Redfish, along with example fabric types. We also have some educational videos focused on the fabric model available. This brings us to the end of the CXL support video. Thank you for watching today. For more information, you can visit the DMTF website at dmtf.org, or you can visit the Redfish Developer Hub at redfish.dmtf.org.